Good afternoon, everyone. Thank you for joining me in my talk today. So today, I will be speaking about Scotiabank's journey towards accelerated analytics using GCP. Unfortunately, Vipul couldn't join me, but he was involved in the GCP project and this presentation equally. Moving on, so a little bit about us and who we are. So we are a team of around 14 data scientists and machine learning engineers. And so we are not the only team in Scotiabank who are into analytics and data science, but our team works in the international banking sector. So we are working on the data of around 12 countries and in the South America. So we get the data from South American countries, and in Toronto we have the Center of Excellence, where we develop some advanced analytics solutions and try to maximize the customer value for Scotiabank in later. So how do we do it? So we have high level of model sharing and reusability among teams, and for each country we have a product, but we make sure that we have some reusable codes and features so that it could be used in another country, and this makes our work very fast. And we also have top-notch analytical talent so that we can have quality products and delivered in a timely manner. So describing our MLOps lifecycle in 7 integrated and iterative processes. So starting with model development, we develop the model on Jupyter Hub. So basically it consists of experimentation, then doing any analysis, then followed by any requirements that are required for model training, then followed by gathering all the packages that are involved in the model training, followed by the continuous for sometimes the model training requires like long training, let's say 14 to 15 hours. So we package it in a pipeline and try to make a single pipeline and run it for using various orchestration workflows. So there's a lot of back and forth between model training and the continuous model training step. And once we have finalized the model that we are going ahead for the deployment, we package the prediction or the inference pipeline and then deploy it in the model serving step. So here again, we have the orchestration workflow to actually serve the model to the stakeholders so that they can use it automatically. And once the model is deployed and served, we have a BI dashboard where we can continuously monitor the models. So there are there could be some data drift or some other changes in the model which can flag us that the model needs to be retrained or there's an issue with the data quality. So along with all these 6 steps, there's a step called data and model management. So we try to version our models as well as control the data quality or the features using the data and model management techniques. So in order to do all 7 steps, we try to establish a single platform so that there's an integrated workflow for all these 7 steps. And secondly, what we targeted was to have a streamlined deployment for using low-code or no-code solutions so that we spend more time on improving the quality of the features or experimenting with the machine learning techniques rather than data ingestion and the model deployment or the serving pipelines. So in order to come up with a solution for the whole MLOps lifecycle, Scotiabank went ahead with the cloud cloud service, and we chose GCP as one of the cloud service. So why we chose GCP? So there were like few benefits in using GCP. The first one was like, as like most of the famous cloud services are, GCP is also seamless. There's a tight integration between various GCP services where there's like correlation between all the services, so it becomes easier to handle the data migration from one service to another. And then because there could be some projects that are in Python or Java, so some of the use cases are using Java as well in our team. So it is easy using GCP to have our MLOps lifecycle within the GCP, so that it's easier to follow one same solution for the MLOps. Then it is easy to scale our applications. So using GCP, we can use GPUs or CPUs and scale our production whenever required. And secondly, the very good service provided by the GCP is the BigQuery. So as you all know, Scotiabank or the banking sectors have a lot of data. The daily transactional data is so much that there's an issue when we want to ingest the data. So with the help of BigQuery, it is possible to ingest the terabytes of data within few seconds. So in addition to that, we have Dataproc and Dataflow that could help make this data ingestion process seamless. And the third benefit of using GCP is that it is more reliable and secure. So one good thing about the GCP cloud is it is available all the time. So there's less downtime with the servers. So whenever like stakeholders need it, it is available. And similarly with the data availability, because there's data replication at various data centers, so data is available and there's low downtimes as compared to the on-prem. So, and the third point is the secured services through the data encryption. And GCP also provides identity management, there's a service called tenant management system within GCP. So even not only speaking on the Scotiabank level, even each of the teams have their own tenancy with the GCP. In that way, my team cannot see the data of the other team. So that way, the data and the very sensitive customer data is secured on GCP. And lastly, we have Vertex AI on GCP, which is a unified solution for all the machine learning tasks, starting from data readiness, then training, validation, and then finally deploying it. So Vertex AI was launched in 2021, which made GCP as a very good contender for a cloud service in our bank. So let's explore the GCP tech stack which Scotiabank is using. So we see it as in 3 parts. So first of all is getting the data ready. So, and the second part is using this ready data on Vertex AI to train, validate, and monitor the models. And thirdly is the composer part where we orchestrate our workflows. Here we do continuous training, or we deploy our models or the prediction pipelines on the composer. So again, once the model is trained or the inference pipeline is run, the results are stored back to the cloud storage. So we'll dive into each of these 3 parts one by one. So starting with the Google Cloud Storage. So we ingest our data from LATAM countries to Google Cloud Storage. And then we mostly use BigQuery to query the data. And mostly our team works with the big data. So BigQuery feature adds a great value to our workflow. So what is BigQuery? BigQuery is a serverless solution provided by GCP where we can query the data as well as run some transformation, which is called pre-processing or preparing the data for model training, store the data, and it also has the capability to do some advanced analytics. So there are like few steps. We first of all use the data that is already stored on Google Cloud Storage to BigQuery, and then we have to create a table in BigQuery in a form of .db format or a database format, and then comes the transformation step. So this step has all the parts of like you can say like encoding or standardization or any other pre-processing step that you want to do. There are like some pre-built packages as well as you can customly do it. So we have done custom transformations using simple lookup tables as well. And then once the data is ready, you can load data back from BQ to GCS so that you can use it in the next step for the model training. And in particularly speaking about the financial services, it is more safe if we use Google APIs to use any of its services rather than the interface. So here's a small demo of how we use the BigQuery API. As you can see, we first of all construct a BigQuery client, and then I have a query, a very small query, which is related to a public data set. So then we have an API request. Similarly, we have, like this is a very small example of how you can use BigQuery. We have very complex pipelines which can transform the data and standardize it and make it ready for your training. So the next step is the Vertex AI. So Vertex AI is a solution which has features like once it uses the data that is stored in Google Cloud, and then you can do various things. You can develop your model. You can use Workbench for the model development. Workbench has a capability of providing Jupyter notebooks. Then you have model training, then model management, model versioning, followed by batch prediction. There's also a feature store, which is an added advantage of using Vertex AI, and that could be really beneficial when we want to use the features in the cross teams. So coming to the first part of the Vertex AI, data wrangling. Why data wrangling was important to us? So because as I already mentioned, we are a team of data scientists working on different countries. So if, for example, a person developed a propensity model in Colombia, might have found some very nice features that are working, that increase the quality of the model. So it could be beneficial for person working in another country to reuse the feature. So in that way, it helps us to keep a track of what worked better, and then it also reduced the difference that you would see between training and the serving skew. So it make the life simpler for machine learning engineers, and then it also has the capability of monitoring feature values. So earlier we used feast library, but it did not allow us to monitor the features. But with the capability of GCP, we can also monitor the features and see what are the changes. So as in the image, you can see like we define various features, and for each like in the feature store, we also have to define the entity so that the data sets can be merged and it could be used where it is relevant. And there are like descriptions for each of the features. The next step is the model training and model management. So here the first step is to look for any pre-built containers. So speaking of very common classical machine learning examples, you could be working with XGBoost, TensorFlow, PyTorch. So the biggest advantage of Google Cloud is that it has some pre-built containers which reduce the coding for the data scientist, and you can spend that time in having some quality checks or experimenting more with your model. So we try to use pre-built containers as much possible, but if it is not available, or if we are using some libraries that are unique, then we have some build some custom containers. So, so here again, reusability comes into pictures for our team. If it is being used in some of the countries, we make sure that it is built in such a way that it could be used in other countries as well. And then we have the feature of monitoring the logs and metrics. So the main steps are, like, we first set up the environment, install all the dependencies that are required for the project, and then we containerize the training code in the Workbench, which is the model development platform in Vertex AI. Then we submit the training or the hyperparameter tuning job to the Vertex AI. So a snapshot of it could be seen in the picture. So as you see, you can see various logs. Here you see either logging statements or the print statements, as well as it shows how much what is the memory consumption and other log metrics. So once you have trained the model, there's a feature where you can create a model resource. Now, what is this model resource? Model resource is related to model management. So it is a sort of versioning system for model. Once you train your model, you can store your model, give it a name, and store it in GCP's model repository. Now, this model could be further used in your batch predictions or predictions, continuous model for predictions whenever required. So it is easy to maintain different versions of the model. So as you can see, there are like, on the picture, there are like different names of the model, and it also shows the status and the time when it was deployed. Coming to the last step that we do in the Vertex AI, it is the batch predictions. Now, what is batch prediction? So it is the single inference request when we have a lot of data accumulated. So mostly in retail banking, we run campaigns and we have a lot of accumulated data every month. So we run a batch inference on the Vertex, on the model that we have trained. And in this, we have to specify the input source of the data and the output location. And here, the data is again referring to the feature store that we visited in the first slide of the Vertex AI. And then another advantage of using batch prediction on Vertex AI is it is scalable. So it could be possible that, for example, sales might just blow up in some of the month. So you might need to scale your batch predictions. So it is easy to scale it that way. And again, we use the batch prediction API for predictions. So it is taken from the AI platform library provided by the Google Cloud, and we provide various inputs like job display name, the input and the output source, the accelerator if it requires any scalability. So it can all be specified within this API. Now, moving to the favorite part of mine. This is the last part of the GCP tech stack that we use. It is the composer part, and it is basically orchestrating your workflows for training and predictions. And why it is my favorite? Because if my model is taking 15 hours, I can just sit back and relax. So yeah, let's dive into it. So Airflow is like a service provided by Apache, but Google has a service called Composer, which lets you use Airflow through this Composer service. It is essentially a connection between Vertex AI and Airflow. And what happens is you can, it makes it easier for us to use the on-prem data on GCP. Then you can schedule your job smartly using Airflow. And then another advantage of using Airflow is it has a very good web GUI, which you can actually use that interface and relate it to Vertex AI as well. So you will see all the logs of Vertex AI within Airflow. And as you can see in the image, we have some tasks lined up, starting from data gathering, pre-processing, feature engineering, and then we are training 3 models parallelly, and then finally, model evaluation. And the image on below is the snapshot of the Composer that we had for one of our projects. And it is basically the Composer in GCP that helps us to relate Vertex AI with Airflow. Now coming to the case study of Scotiabank. So we trained a predictive model on the customer data. And a little more about this data. So it is like a batch, it is a batch prediction project, and it has to serve monthly campaign to the stakeholders. And another thing about it is large amount of data every month. So one big issue that we were facing earlier before GCP was that handling the big data. With the big query, we could accelerate the query of the data every month, which reduced the timeline. And then after we ingest the data and transform it, we can train and validate it. So there are various steps involved. So we have feature engineering, data processing, all the steps around the machine learning model training. And then after model selection and hyperparameter tuning, once the model is ready, we go ahead with the testing. And as you can see, we got very good results on the prediction of a certain target variable. And the absolute error was around 0.64. And then once we are satisfied with the model results, we go ahead with the prediction. So this prediction pipeline is again deployed on Airflow using the Composer service of the GCP. And all the results are stored back in Google Cloud Service, Google Cloud Storage. And it could be checked, it could be either downloaded to your machine, or it could be checked through the Workbench Jupyter Notebook. So that was a short snapshot of one of the successful case studies in Scotiabank. So in today's talk, there were like 4 main key takeaways. We talked about Scotiabank's MLOps lifecycle, the tech stack of Google that we were using, and then how we are using the Google Cloud to do the machine learning model development. Then we showed how we leverage GCP's Vertex AI for model training and serving patterns. And then the most essential part is the secure handling of production data on Google Cloud Platform, which is very essential for the banking institutions. And lastly, we showed how we could successfully use GCP to serve our predictive model on GCP. So yeah, that was our story about GCP, and I am open for any questions if you have.
Hello, thank you for the presentation. My first question is, do you have any example in Scotiabank where you had to serve not only the model, but a solution on top of the model. So for example, you have a model that have a prediction, but on top of the prediction, you have to give business a rule or a flag, right? Do you have any example and how you treat that with GCP?
Right, like there are situations where stakeholders ask some more post-processing, we call it post-processing on the output. So in that case, we use, the most ideal way is like to integrate Google Cloud Storage with the Workbench on Jupyter Hub. And then if there are any requirements, special requirements from the business, then we use just the Jupyter notebooks and provide it. But if this is repeating again and again on monthly basis, then we try to include this step within our Airflow prediction pipeline, so we can create another task. And Airflow provides various operators, so it doesn't have to be just the Python operator. There are like lot of operators. So if it is a special request which needs, some special requirement, it could be Spark or any bash operator. So we could make another task and automate it for subsequent months.
Okay, thank you. I have one more question. So
Sure.
you spoke about having a way to manage, sorry, I'm just trying to remember my question. Try to manage the experimentations over different countries, and then later you have to, like once you're seeing that there is value on a specific experimentation, then you make this something that would be a standard for all the teams. So how it's, like can you speak about the challenge or maybe some advice on how you define these best practices across the teams and how it's basically how you manage all of that? It's like your team that do that, it's something that you have a special team to do the organization and the maintenance of that, or something that is on the culture of your team?
Right, so I can give you an example. So speaking of XGBoost, which is already a pre-existing container in GCP or the Google Cloud services. So what we can do is like create an image that is generic. So and it is supported by another configuration file. So team-specific details can go into the configuration file, and very generic like XGBoost or XGBoost related steps can go into an image that uses the generic container. So yeah, does that answer your question?
More on the management side. So if one team in Colombia defined that they need a new container that is going to do experimentation based on a new library or a new algorithm, and then you define that they went through extensively, they find the best way to do it, but it's not something that was already defined, it's something that they have to create a container for that. How do you manage the containers across different teams? So once the team in Colombia said that this is the best, this is my container, how do you spread this information? So this is more on the culture side, how do you spread this information and make that all the teams across different countries use the same and maintain the same best practice considering creating new containers and then using that?
Right. So right now we do not like right away change the process for every team. So if it is working fine for one country, then we slowly go ahead and change it in another countries. But that is again based on the requirements and how the previous model is performing. If the previous model's performance is going bad, then we go back to the previous any country that performed better, and then do the same strategy what we have in the existing team or the country.
Thank you for the presentation. I just have a question regarding the feature store in Vertex AI. I just wonder how do you compare that to Feast? They mentioned in this conference.
Yeah, I actually couldn't attend that talk, but I'm guessing that was based on Tecton. So what I know about Tecton is it has capabilities to monitor the data and the model, And similarly, GCP also has those capabilities. However, there's another library called Feast, which does not provide features like model monitoring, and Google Cloud is the like advanced version of Feast. So yeah, Tecton and Google Cloud provide similar services when it comes to the feature store.
Hi.
Hi.
First of all, thank you for the presentation. I'm just wondering, do you know how much time and resources was needed for the team to make the whole transition from whatever your previous ML workflow was to like the whole GCP ecosystem?
Right. So there's a synergy between a lot of teams within the bank who are involved. So starting from data engineering teams, data scientists, machine learning engineers, and then there are like a lot of management folks involved. So I would say it started like back in 2021, and we were able to deploy the first model by the end of 2021. So yeah, just about that time.
All right, thank you.
Thank you for the talk. I have a question regarding the set of tooling with GCP. What did the interaction between the data scientist team and the technology team, what was that interaction in terms of determining this is the tooling you want? Was it something that they defined and then you made use of, or is it something that you gave as a requirement and they kind of built it out?
So I think it is different for all companies. So how it works in Scotiabank is the technology team provides some starting point for the data scientists to start working on with the machine learning projects. So usually they're in a very mature technology, there's like some pre-built images that are made by technology team that could be used by all the data scientists across the bank. But when any platform is very new, then it is like a synergy between the two teams. So technologists and data scientists work together to get started and make it work.
Just a follow-up question on that. So for example, the tooling on Vertex AI, was this something that, let's say, the data scientists looked at and they requested the technology team to add this into the stack, or was this something that they offered up front and you just looked and it made sense for you?
No, so to start with, like being the very first users of GCP, we only got the platform that was tested, user tested by the technology team, and then we started building from the predictive, for the predictive model, and building any containers or images that could be required, and then we went forward with as per requirement of the use case.
Thank you for your presentation. Because you mentioned BigQuery, are you building your models using BigQuery ML or scikit-learn, for example?
Yeah, so we have tried both strategies. So for BigQuery, currently, what we initially tried was actually training models, very simple predictive models. But eventually, what we are doing is using BigQuery only till the transformation process, and then going ahead with other libraries on Vertex AI, like using scikit-learn or whatever library that we want to use to train the model.